Sorry, say that again. I want that on video. What was that about coffee, Margot?
Oh, it's an integral part of the process.
Thank you. I love it.
Okay, so what we have done so far, first we built our sections of wall on the ground, on our lovely floor, and then we raised them up individually and tacked them down.
What do you mean by tack them down, Margot?
Put a couple screws in.
Great.
And then made sure that, or tried to make sure that they were upright and squared. And then we braced them with these posts out there. We also had diagonals on, we still have diagonals on here to help keep things square. Right now, just took the diagonals off these walls because the walls are a little bit leaning this way and we need to pull them so that they're upright. And then put those diagonals back on and keep them in square.
Okay, and by upright, what do you mean?
Like at a 90-degree angle with the ground.
Yep, which means we found out that...
we used our level.
Awesome.
Yeah.
So we're leveling our wall, we're using our level to check our walls, and we're off on our north wall. South wall looks good, but we're off on our north wall.
Yeah.
Just a little bit.
And, I mean, we had to work a little bit to get the south wall.
Let's be our own building inspector on these walls, since there aren't any where we live. Pause the video right here and see if you can see what's wrong with this wall. You're looking up at the ceiling where the rafters come in at the double top plate up there. So there's your rafters, which means what? This is a load-bearing wall, right? It's got to transfer the load of the rafters down to the floor across our double top plate. So we're going down towards our window on our cripples, but wait, what? I can see a lot of the bottom of my cripples. And then I've got this jack stud here, and I've got a king or a queen on the other side, like I should in my wall. But what am I missing? What's not in this wall right now? Yeah, a header. Our cripples are only hanging out on 1.5 inches of stud at the most, and our jacks aren't transferring the load. Look at another window in this load-bearing wall and pause and see if you can see what's missing. Yep, you have part of your window member coming down. That should be a jack, but where's the rest of the jack? And on the other side, you have what looks like it should be either a jack or a king, but it's hanging out in midair. Good news is, I know these aren't the walls that you are going to build. You will build walls that will transfer your load how they're supposed to. Now when it comes to raising walls, this is where you want to ask for help. So in our case, we don't have sheathing on these walls, so 3 of us can lift it. We had to move it over to the outside because remember we had to build our walls backwards. And then all 3 of us lifted it, and then we put it in position. And now it's time to put on bracing. So one thing about walls, especially if you have any wind, or in particular if your walls are sheathed, you can almost never have too much bracing because the last thing you want to do is have all your walls fall over. What we're doing on this wall is we're adding bracing on the outside with rebar stakes that we pound into the ground, and then we screw those 2x6s or 2x4s that we're using as bracing into the rebar stakes. We will also add some bracing to the inside because we have a wood subfloor. We can also add bracing to the inside and screw to our wood subfloor. This building is so small, it's harder for us to do interior bracing, but on a bigger building, this will be really easy. In my ideal world, I don't raise a wall unless I have another wall to support it to make a strong corner. One wall is pretty floppy and hangs out. 2 walls means I can make a corner, and then I can even put an angle brace up top across both of those walls and really make it secure. 3 walls is even better. Keep checking your walls with the level at this point and plumb them as much as possible. You will keep having to check them with the level, plumb them, move in and out as you raise other walls and as things move and tweak. But the more times and the more chances you have to get your walls as level as possible and as plumb as possible, the easier it will be overall. For wall sheathing, remember if I'd been able to build my walls the way I normally would have if I hadn't have rounded headers, I would have put wall sheathing on when they were sitting on the ground. But because we were building these walls opposite, we went ahead and put wall sheathing on after they were standing. It also made our walls easier to lift, so there are some advantages. When you put on wall sheathing, remember you want to make sure you overlap on a stud, so ideally our wall layout accounted for all our sheathing. But here on the south wall, this is where some of our sheathing layout got tricky, because we have two independent walls here. We've got the lower south wall, wall 1, and then we've got the upper, the taller south wall, wall 2. And where they come together, I know it's hard to see here, but there's a plate break in our bottom plate right underneath those two walls. So we really want to unify both of these walls together and hold our building together through there with our sheathing, which means we have to strategize our sheathing differently. I also want to point out a couple other things in this wall while we have it standing here. Up top there you see I have an insulated header and I have a solid header. The insulated header is small and wasn't carrying as much of the load. The big solid header was in the kitchen with a very big window. Anywhere you can do insulated headers to improve your R value, that's a good idea too. So we went to put on our first piece of sheathing on the south wall, and we had 3/4 of an inch overlap where we were going to connect two pieces of sheathing together. Remember, we're splitting a stud down the middle, so that was good. But what happened there between wall 1 and wall 2? Now we don't have any overlap between wall 1 and wall 2. The plate break is still broken right where it is, and this piece of OSB won't unify our two walls. So if we turn this OSB, all of a sudden we now have a sheet of OSB that has 3/4 of an inch on a stud. That's great. That means we have room to screw in both sheets of OSB. But we also have at least 2 feet on either side of this wall joint where wall 1 and wall 2 come in. It also means our OSB is overlapping our bottom rim joist, it's connecting to our bottom wall plate, and it's connecting to our top rim joist up there where I'm standing. So wall 1 and wall 2 get unified with at least 2 feet. That's the minimum you need for a shear panel to keep your building from shearing, from pulling either direction and doing that parallelogram on you. Great, we've solved it.
And your building department, if you live in somewhere with building codes, will have a number of screws or nails per inch on your edge seams and on your middle framing members. You should adhere to that. They will be inspecting it. We don't have a building department, so we're going off of the building codes we last used. We're still using screws. We're using 2-inch exterior grade structural screws because we get things wrong and we want the ability to take this piece off, which we've actually already done, and turn it the other direction if we have a compelling reason to do so. In this case, we're running the sheet vertical because we wanted to overlap our top plate all the way up there, and even though you can't see it in this video, all the way to the bottom of the bottom floor joist and sill that our building is sitting on. So we're basically unifying the whole building with our sheathing. We also, you can see we ended up with an extra big gap here. This is our biggest gap. This would ideally be 3/8 of an inch less. It's right over a framing member and we had enough to screw into on both sides. So I'm not super worried about it. It's not what I would have wanted. It'll still work. And part of that is because if we cut this off at 6 feet, we ended up with this gap on the sheathing here. Something in our layout got 3/8 of an inch off, which is fine. But we didn't want to waste the extra 2 feet of an 8-foot sheet is going to work somewhere else. So we chose to use our materials and not waste 2 feet worth of material. What we also need to do here is this is a window and our sheathing is overlapping the window. So we need to actually cut out our window. I put a drill bit on my drill. I'm going to go from the inside of the window and actually send the drill through the corners so I know exactly where my corners are so that I can then take my circular saw and go cut this out. So I stuck my drill bit through. I now have a marker for where the corners of my window framing are. Somewhere way up there. There we go. And so I'm going to take my level. I'm actually going to pop through this one too. Easier than looking. Okay, great. I now have my marker. Put some some sort of straight edge on it. Dun, dun. Line it up to both. Ideally, it's pretty level, which it is. Pretty level. Turn your pencil in the right direction. Okay. Mark that. Looks like I should cut on the upper side of this line. Just looking through my handy dandy little gap here that shouldn't be here. I can see I should cut on the upper end of this line. Okay, there. And then here, I should have 2 corners as well. Great. I have marks. Now, this is where setting your saw depth is really important. We want to set the saw depth because we're going to be cutting right against the sill. We want to set the saw depth pretty much exactly to the width of our OSB here. So I'm going to put it on the side. I'm going to unlock my base. I like it. I think I like it. We'll test to see if I like it. And this is a little bit of a tricky part when you're sawing and you're dropping into something. So I'm actually going to hold my blade up, put my foot on where I want it, and I'm going to slowly drop my blade into this OSB to start my cut. It's certainly a more dangerous move. It's certainly a good one to practice. But it's also how you can drop your blade in to an area that you don't have a previous cut into. And it's just, yeah, it's one of those things you just have to start trying and doing. Obviously, I have to get my blade guard out of the way in order to drop this. So I roll it forward with my hand on the handle, and I'm holding the blade guard by blocking it there, so my hand is still clear of my blade, and I'm very slowly lowering my saw into my OSB. So rolled forward, so it's exposed, get on my line, start my saw spinning before I hit the OSB. I'm not going quite through my OSB. Looks like I'm a little shallow, so I'll go back and do that again. But you saw how I dropped the saw in, started it, and then went to cutting. These corners I'll have to either get a handsaw to cut out because I can't get my blade all the way into the corner, or one of my favorite tools, a multi-tool, which we'll do in just a minute. Yeah, I'm just a little shallow. So now I'm free there. Okay, and this is where my corner's stuck. So far, this is my favorite multi-tool. DeWalt makes it. It has a quick release blade, so I can put blades on and off. This is a vibrating, it just vibrates the blade back and forth, reciprocating back and forth. It's really relatively safe because the blade is in a very small area. It's much harder to cut yourself. The best tool for remodels. A multi-tool. They make different blades, wood, metal, tile, all sorts of things so you can get into really annoyingly small areas. Like this little corner here. Voila! Okay. I am a good level right here. I'm a little high right here. I'll probably come back in and buzz this out with the circular saw, take just a little bit more off. But I'm getting my windowsill cut out. And probably just a touch more there. I don't want my sheathing to interfere with how I mount my window into my window framing.